Stop scrolling if you care about the future of artificial intelligence. We are standing on the precipice of a massive shift in how machines process information, and it all comes down to one thing: precision within context. For years, we've been limited by short windows of attention, forcing AI to summarize vast amounts of data into tiny snippets that often miss the nuance. But today, Anthropic has unveiled a new era with models like Opus 4.6 and Sonnet 4.6, featuring a staggering 1 million token context window. This isn't just an upgrade. It's a fundamental change in how intelligent systems understand complex documents, massive code bases, and multi-hour analytical sessions without losing track of the initial instruction. In this video, we will break down exactly what makes these new models different, why they solve the critical bottleneck of long context processing, and what this means for developers, researchers, and anyone trying to build truly autonomous agents that can think deeply about huge amounts of information all at once. For a long time, the biggest constraint on AI was simply how much it could remember at once. Think about trying to read a novel while simultaneously debugging a complex software architecture or reviewing legal contracts spanning hundreds of pages. Traditional models would hit a ceiling, forcing developers to chunk their data into manageable pieces and lose the big picture in the translation process. That is no longer an issue with the new generation of Anthropic models. The introduction of a 1 million token context window allows these systems to hold entire books, massive repositories of code, or days' worth of meeting transcripts in their working memory all at once. This means you can feed an AI a complete software project specification and have it understand the interdependencies between every single file without needing to break it down into smaller segments first. The inference bottleneck that plagued earlier long context attempts has been effectively removed through technical optimizations in logical reasoning depth. This capability transforms how we approach data processing, allowing for a seamless flow of information where the system never needs to summarize or lose track of the original prompt, even as it navigates thousands of pages of content. With so much context available, you might assume the quality of reasoning would degrade simply because there is more data involved, but that is exactly what these new models have solved. The core innovation here lies in technical optimizations designed specifically for logical reasoning depth within a massive context window. When you upload a complex legal document or a sprawling codebase, old models would start to hallucinate connections or miss the subtle constraints buried deep within the text because their attention mechanism fatigued. The new architecture prevents this by maintaining high-fidelity recall of every token in the input sequence relative to its position and relevance to the query. This allows the AI to pinpoint specific clauses in a contract that contradict others, or trace a bug through layers of code written by different developers months apart without losing track of the original requirements. It is about precision. The system doesn't just read faster, it understands deeper. This level of accuracy in long context handling means that autonomous agents can now operate on enterprise-grade data with the confidence of a human expert who has spent hours reviewing the same material, rather than rushing through it. The real magic happens when you combine this precision with autonomous agent workflows. We are moving into an era where AI systems don't just answer questions. They plan and execute complex tasks independently over sustained periods of time. With the ability to maintain a 1 million token window, these agents can reference their own past actions, previous outputs, and entire project histories as part of the same continuous thread of logic. Imagine an agent tasked with migrating a legacy system to a cloud environment. It would need to remember the original architecture diagrams, read through the new API documentation, write thousands of lines of code, debug errors, and then review its own previous decisions to ensure consistency across all changes. Without this level of context retention, every step requires constant human intervention to reorient the AI. But with these new models, the agent can work for hours or days without losing its place, effectively simulating a team of highly specialized humans working in perfect sync. This capability is particularly powerful for design and engineering tasks where continuity is everything, allowing for truly self-sustaining projects that require no constant oversight once initialized correctly. So what does this mean for you and your workflow right now? The practical takeaways are staggering. You can finally build applications that ingest entire datasets without preprocessing, enabling real-time analysis of massive archives or continuous streams of data with zero latency loss due to context limits. For developers, this means writing more robust code that includes comprehensive error-checking logic based on the full scope of the project rather than isolated snippets. In legal and financial sectors, it allows for instant review of entire case files or investment portfolios with a level of scrutiny previously impossible. The ability to handle such vast information loads at mid-tier pricing makes these tools accessible far beyond just enterprise giants. It democratizes access to deep analytical power that was once reserved for supercomputers. As we look forward, the trajectory is clear. The line between human oversight and machine autonomy will blur further as these models become standard in our daily digital interactions. We are entering a new phase where complexity is no longer a barrier to intelligent systems, but rather the fuel they run on. The landscape of AI has changed forever with the release of models like Opus 4.6 and Sonnet 4.6. By solving the long context bottleneck, we have unlocked a future where machines can think deeply about massive amounts of information without losing their way. This isn't just an incremental improvement. It is a fundamental shift in what intelligent systems can achieve. From autonomous agents running complex projects to deep reasoning over entire code bases, the potential is limitless. If you found this breakdown insightful, make sure to hit that subscribe button so you never miss an update on the latest breakthroughs. Drop a comment below and let us know. Do you think we are ready to fully delegate complex tasks to AI agents today, or should we hold off? Thanks for watching, and keep exploring the future of technology.